Hi, my name is Hari Subramaniam, and today I will talk about a process model for UX professionals and AI engineers to collaboratively design AI experiences. This work is co-authored with Colleen Seifert from the Department of Psychology and Eitan Adar from the School of Information at the University of Michigan. Imagine designing a phone unlock user experience by taking a human-centered approach. As a designer, you will first try to understand how end users use their phones and what their security concerns are. You will then translate this understanding into specific design needs, such as quick to unlock and low cognitive effort to remember. Next, you will prototype different solution alternatives based on needs such as numeric key code, alphanumeric password, and pattern-based unlock. You will then gather feedback from end users and determine that a numeric keypad is the best solution. At this point, you have fully specified the software design for a phone unlock user experience, including interface details, interaction, and the overall system behavior. You will then hand off the specifications to the engineer to build. Now imagine designing an AI-based phone unlock user experience, one that uses facial identification to authenticate the user. The user interface itself is quite simple and consists of a blank screen with a lock icon. And this interface experience should work for diverse users in a variety of usage scenarios. Unfortunately, unlike conventional software design, designers cannot fully specify the human-centered AI experience at the user interface level alone. Design extends beyond the interface and into the design of AI subcomponents, including model behavior, implementation, and training data. And because building AI software requires writing meta programs to learn from data, engineers cannot build systems to exact specifications. An alternative, and this is a prominent approach in real-world settings, is to take an AI-first workflow. That is, AI researchers and engineers will first develop the AI capabilities, and then designers will create user experiences around those capabilities. With this approach, the idea is that designers must consider AI as a material for design. Just as how woodworkers need to first understand the grain of the wood to design with it, HCI designers should treat AI as a technology design material and explore its capabilities and limitations in order to design AI experiences. However, as a created material, AI is deficient for design. For instance, as seen in the gender shades paper, if we discover after the fact that AI does not work for specific subgroups of population, not only are they harmed, but refactoring AI after it is created requires costly reworks. In this paper, as opposed to an AI-first or UI-first workflow, we investigate how designers and engineers might co-create human-centered AI experiences from the ground up. Specifically, we conducted an in-lab design study with UX designers and AI engineers. In each session, one UX designer and one AI engineer worked together to design AI specifications as well as user interface design for a given problem. Each session lasted around 2.5 hours, and we conducted 10 sessions in total. The design problem was to create an AI-powered experience to declutter photo albums on the phone. Computer vision with image data offers a rich design space and contributes to a variety of AI experiences. The domain of decluttering photos is simple enough for our participants to understand and engage in the design process. We also provided participants with a set of personas, which is typically done as part of user research. For each persona, we gave them a collection of 15 recent photos taken by that persona. We based our study protocol on human-centered AI design guidelines from various industry resources. At a very high level, participants first brainstormed opportunities for incorporating AI into the photo deletion workflow. Then they discussed ways to implement the model, including rules, assumptions, and constraints. Next, they designed the user interface and corresponding model APIs. And in the last step, they designed for AI's uncertainty, including identifying errors, explainability, learnability, and setting end-user expectations about the AI. We used qualitative coding to analyze the transcripts and the artifacts generated in each session. We did a first round of deductive coding based on literature and the study protocol steps. Next, we conducted inductive coding for each set of excerpts in the deductive codes. I will now talk about the key findings from this analysis. Starting with the notion of AI in the abstract, the designers and engineers worked to identify specific AI behavior to support the declutter experience. Across all sessions, the designers used the photos from data personas as design probes and constructed scenarios around why their end users have cluttered photo albums and how they could use AI to delete or archive their photos. Through these user scenarios and vignettes, designers participated in brainstorming potential AI capabilities without detailed engineering knowledge. For example, in one of the sessions, by looking at the burst of photos from the dad persona, the designer questioned whether AI can identify duplicate photos and find the best one to keep. To this, the engineer responded, yes, we can cluster images based on similarity. In this manner, by constructing different scenarios, our participants brainstormed a variety of AI behavior, including image quality assessment, object recognition, as well as text processing. Next, after identifying high-level behavior, our teams worked on determining specific assumptions and constraints for implementing those behaviors. In this step, the designers engaged in what we call cognitive walkthroughs of how their personas might make decisions about decluttering photos across the different scenarios. Through these walkthroughs, they developed expectation models for the end users about what the AI can be expected to do for them. During the walkthroughs, the engineers listened and translated user expectations and decision factors into features, rules, and even pseudocode for training their models. For instance, when brainstorming criteria for finding the best photo to keep from a cluster of similar photos, the designer questioned whether AI can detect blurry photos. In this manner, the teams identified several factors, including lighting and shadow, instances in which a person's eyes are closed, whether the individual was smiling, and so on. Next, teams proceeded to prototype the user interface and APIs between the model and end users. Based on the model's implementation specifications, the designers and engineers negotiated what inputs they should expect end users to provide and how to format and present the model's outputs back to end users. In one of the sessions, the designer anticipated a large number of photos recommended for deletion, and they questioned if the model can intelligently organize the photos into smaller groups based on reason. The engineer responded that images could have multiple reasons for deletion, and then the team proceeded to discuss how they might assign different weights to the factors and surface the primary reason for deletion. Across all sessions, the designers and engineers used individual data points as content common ground for collaboration. Using data probes, the designers advocated for end users when specifying model details and simultaneously evaluated different assumptions by considering diverse data. For example, when designing smile detection as a potential solution for decluttering photos, the designer pushed back that if a person had a stroke and could not smile, then deleting that picture would be wrong. By acknowledging this concern, the engineer added that models could be error-prone, especially in instances of, say, missing teeth or braces. Based on these findings, we propose an initial process model for the collaborative design of AI experiences. As opposed to a UX-first or AI-first approach, in our model, the AI and UI components are designed in parallel, a key insight from our study. This is indicated by the bidirectional arrows in the model. Such a model distributes agency between designers and engineers. By using personas, scenarios, walkthroughs, and interface prototypes, designers can participate in designing AI specifications without detailed engineering knowledge. Our approach shifts engineers' mindset towards more proactive engagement in the human-centered AI design process. Further, through data probes, designers and engineers can engage in divergent design thinking about AI capabilities and UI needs, and they can mutually constrain convergence towards a design solution. To learn more about our conceptualization of design materials and data probes, for details about our study protocol and implications for creating AI experience design tools, please see our paper, and please email me if you would like to chat about this work. Thank you for watching.